Ladies and gentlemen, in this March, a security researcher called Max Kellerman has disclosed a critical, notorious Linux kernel vulnerability. And that vulnerability is called Dirty Pipe. Yesterday, TryHackMe has released a room that talks about this Dirty Pipe vulnerability at higher level. So once I witnessed that room, I thought, why don't I go through this room and make it as a video? Hence, I'm here. So without wasting a time, let's begin. Here is the TryHackMe's room that I was talking about, Dirty Pipe, and the vulnerability ID is CVE-2022-0847. Interactive lab for exploiting Dirty Pipe in the Linux kernel. So here is the topics. They gave the introduction and the deployment of a machine. They gave their own machine. It is vulnerable to Dirty Pipe, and we can try the exploits they gave over their machine. And also, they gave a little bit theoretical background to that vulnerability. The exploitation part is very, very simple. All you need to understand is the theory behind the specific Dirty Pipe vulnerability. Let's begin with the introduction and deployment. In March 2022, a researcher named Max Kellerman publicly disclosed a Linux kernel vulnerability named Dirty Pipe. And because of its similarity with Dirty Cow vulnerability, actually, it is pretty much a old vulnerability found in Linux and that allowed attackers to arbitrarily overwrite files on the operating system. So here is the properties of Dirty Cow. And Dirty Pipe vulnerability is similar to this arbitrary file overwrite, and that is why they named it as Dirty Pipe. So the vulnerability was responsibly disclosed in early 2022 and was publicly released in a blog post written by Max Kellerman soon after patches were made available. So here you can see the responsible approach by the researcher Max, and arbitrary file overrides at the kernel level can be easily leveraged to escalate privileges on the machine and to obtain administrator or root privilege. So this is the spooky thing about this vulnerability. This vulnerability, I mean, by using this vulnerability, anyone can escalate their privilege and they become root. This is the devastating vulnerability made more so by its reach. Any devices running vulnerable Linux kernel version is impacted because of this. And Android phones are also affected. If the Android phone is running that specific infected kernel version. And this room will provide an overview of the vulnerability. Once again, I'm saying this is just a high level. I mean, this room is just for getting a high level understanding, as well as give you an opportunity to exploit it for yourself in the vulnerable machine attached to this task. We will start by taking a look at the vulnerability and exploit at high level before moving on to exploiting the vulnerability in subsequent sections of this room. Okay, so this is just an information I'm completing here. Moving on to the second task, the exploit background. You have to pay your attention more in this exploit background. You have to understand why it happened. So let's try to understand it the high level overview. Due to their low level nature, any in-depth discussion of kernel vulnerability quickly becomes rather complicated. So they provided a light information on this vulnerability. If you would like to read in-depth explanation of this vulnerability, you can. They also gave the link to this Max Kellerman's original blog post, and I opened this specific page and I tried to read this explanation given by Mr. Max. And actually, they he found this vulnerability when he was handling a security incidents, which he was getting the incident related to the file corruption. When he was investigating that incident, he eventually found the bug in the Linux kernel. So that is how he began investigating that flaw. Before continuing with this task, it is important to note Dirty Pipe has been fixed in Linux kernel versions. So here they gave the fixed versions. If you are running these versions of Linux kernel, then you are safe. So if you use to manage any Linux or Android devices, make sure that they are running kernel greater than one of these versions. So that is one of the important things to note down. So let's get into the theory. In order to understand how dirty pipe works, we must first look at how Linux kernel manages the memory. And you have to understand the Linux internals little bit in order to understand this specific dirty pipe kernel vulnerability. So the smallest unit of memory controlled by CPU is called page. So here they gave the definition for the term page, and these are usually about 4 kilobyte in modern systems. Of relevance to this room, pages are used when reading and writing files from the disk. Although they have many other uses, the part of the kernel that manages pages is referred to as the page cache. When a process attempts to open a file, the kernel loads it into page, which are then made available to the userland process. This userland process access can be granted either by being copied into user space memory or by keeping the pages in kernel space but making them accessible via system calls, effectively special functions which are used to interact with the kernel. So if you put Linux system calls in Google, you will be able to see multiple system calls. So let me give an example here. I'm just searching for system calls in Linux. So let's open this link and try to understand. Here you can see the list of commands which is being used to interact with Linux kernel. So that is system call. You can see the system calls here. Pipe, pipe system call. The pipe system call is used to communicate between different Linux processes. It is mainly used for inter-process communication. Pipe system functions used to open descriptors. So this pipe system call is very, very important because this vulnerability is leveraging this pipe system call only. And okay, so what does this have to do with dirty pipe? This vulnerability arises because of how kernel implements pipes. And you will likely to be familiar with the idea of anonymous pipes. Here is the symbol, the pipe symbol. You might aware if you are working on Linux operating system or any scripting language. This pipe symbol is usually used between two separate commands. By getting the output of one command and putting the, and giving the same output to another process as an input. So that is the properties of, that is the work of this pipe character. And the pipes are characterized as having two ends, one for reading and one for writing. You can see this for yourself in a way that anonymous pipes take standard output of process and writes it into the pipe where it can be read by standard input of the next program in the chain. So here is the definition. This line is very, very important. You can see this for yourself. All you need is to understand this pipe function, what the pipe is exactly doing. If you understand this, then it will help you to understand this vulnerability as well. So let's see. You can see this for yourself in a way that anonymous pipes takes the standard output of a process. It takes the output from a process and write it into a pipe. A pipe is like a buffer. You can keep it. You can keep that in mind. A pipe is like a buffer, a flow, and where it can be read by standard input to the next program in the chain. So what the next program does, it reads the data from the pipe. So this specific line depicts. And back onto the topic, the Linux kernel provides a system call called splice. So here is the system called splice, and which is effectively a shortcut designed to speed up the process of pushing the contents of the file into pipe. So we said, right, from a process we need to get the data, we need to get the input and pushing into the pipe. So for that they are using the system call called splice. And this optimization is achieved by moving references to the pages storing the file contents rather than moving the entirety of the data. So this is another important point. In other words, splice allows us to point a pipe at a page which is already loaded into memory. So here is the same definition I said before, containing a section of a file originally opened by a process requesting read-only access. See where this is going wrong. He also raised a question here. And by splicing a page into the pipe, then writing our own arbitrary data to the pipe, we can overwrite the content of the page. So here is an important point to overwrite the content of a page. As I said before, we already seen the definition for this page. The page is a memory that is controlled by CPU. And it is not quite that simple. However, we are still missing one final piece of puzzle. Usually, when you are write to pipe after splicing a file, no changes actually happen on the disk. When you are putting the data into the pipe, there is no change in the disk. Changes are made to the page buffer. Yeah, and but nothing is permanently altered, and the file itself remains unchanged. So here is another restriction that we are facing. A restriction is against us. So how do we force the kernel to write the content of the relevant page back to the disk? So what we need to do now, we need to make the content of the page to be written on the disk. For that, uh, what is the solution? So here, let's continue to read. This is the real crux of the vulnerability. Yes, we are in the dead end, and it can all be traced back in. I mean, traced back to two commits in Linux kernel. Let's see the first one. The bug was introduced in Linux kernel version 4.9 in 2016, which allowed pipes to be created with arbitrary flags. None of the files available at the time were in any way dangerous, so this was not an issue until. And since the Linux kernel version 5.8, which introduced in 2020, added a new flag. Here they gave the flag pipe buff or buffer flag can merge. So in simple terms, they are explaining this specific flag here. This flag tells the kernel that the changes written to the page pointed by the pipe should be written directly back to the file that the page comes from. So this specific flags helps us to, helps the system to write the file, write the content of the page into the disk. So this is how they are uh, fulfilling this specific flaw, specific exploit. And to summarize, we have a flag that allows us to tell the kernel to write the page back to the disk as data comes into it. Just now I explained this. We have a bug that allows us to specify arbitrary flags for a pipe. And we have a system call that inadvertently allows us to point pipes at a page buffers, which were opened as read only, which could possibly go wrong. Again, there is a question mark. Put simply, here is the simple definition. With this, they are concluding the explanation. The exploit first opens a target file with read-only flag set. Okay. In order to do this, we must choose file that we have permission to read. So, in order to exploit this vulnerability, a user must have a read permission to that specific file. Then only they can overwrite the content of the file and modify, manipulate that file. And the exploit then prepares a pipe in a special way, forcing the addition of pipe buff flag can merge flag. Next, it uses splice to make pipe point at the desired section to the target. Finally, it writes whatever arbitrary data that user has specified into the pipe, thereby overwriting the page buffer and by merit of this specific flag, overwriting the file on the disk. So this specific sentence, the paragraph explains how this system call, this flag is being incorporated in this exploit. So let's see the effect of this vulnerability. So what does this all mean? In short, means that with the right code, we can arbitrarily overwrite any file on the system. Any file on the system, if you have a read access, provided we can open it for reading. Yeah. And in other words, if our user has read access over the file, regardless of the other permissions or mutability, then we can also write to it. So this is, this specific capability makes this vulnerability very scary. And interestingly, this also applies to read-only file systems or otherwise protected files which the kernel would usually stop us from writing to. By exploiting the kernel vulnerability and circumventing the usual write methods, we can also bypass these protections. So this is the ultimate effect of the dirty pipe vulnerability. Let's see the remediations given by them. Fortunately, the remediation for this vulnerability is very, very simple. Update your kernel. So you have to rely on your vendor. Patched versions of Linux kernel have been released for supported major kernel versions. Specifically, the vulnerability has been patched in Linux kernel version. So here they gave the version of kernel, the patched version, and ensure that you apply updates to all of your Linux devices, including Android machine, because the Android machines are running on Linux kernel. So that is why we are saying even the Android operating systems are vulnerable to this. So again, with this, we are accomplishing the theoretical part. If you want to understand more at the low level, you can always refer the blog of the Max Kellerman. The link is given here. I'll add this link in the video description so that you can refer. Let's move on to the next one, the exploitation part. And the topic is a weaponized POC. And here they gave their own machine which is vulnerable to dirty pipe, and we can use that specific machine to practice the exploitation. So here is the machine. So before beginning, let's start that machine, and the password is all right. Now we are in that machine, and if I see who am I am try hack me. I'm a normal user. I'm not a root user. In order to find that, you can use the command id try hack me. So I am a normal user, not a root user, and I don't have a sudo privilege. I'm in the directory of the home, and let me verify the kernel version here. And to verify that, I am using the command uname -a. And if you see here, uh, you can see the Linux dirty pipe, the machine name, and the next stuff, the next version number is nothing but the kernel version. The 5.8.0 is an affected version, so we can able to exploit this machine, and we can escalate the privilege to root. So let's see how the exploit. So here they gave the specific POC, the Max Kellerman's POC they took from his blog post, and they are using the same POC here. And if I navigate to the folder exploit and POC, I can see the exploit here. And I am using Nano Editor to showcase that exploit. It is written in C language. You can try to read this exploit line by line and understand at low level. It is a time taking process. However, you are welcome to do so. And we need to compile this C program, the POC. And once we compile, then it is ready to trigger the exploit. And exploit gives us a lot of control over how we abuse the dirty pipe vulnerability. Specifically, it lets us specify the file we want to overwrite, the offset we would like to overwrite it at, and also the content we would like to insert. And the property of this vulnerability is overwriting any file onto Linux system. So by using that specific line, we can try to manipulate any critical file so that it can give us the high privilege. So we are going to try that, and we will acquire each of these things in the following paragraphs. They also gave the interactive video clip at the bottom, so we can go through that in a moment. So bearing in mind that the exploit won't create any file, it won't create any file. Instead, it will simply manipulate the content of the file. So we are going to use that property. We are manipulating that property and taking the privilege. And we first need to find a file our user can read, but that still allows us to elevate our privileges. The obvious easy choice is in these conditions is etc password. So what they do, what they are given here is they are exploiting, they are manipulating the etc password file. Some of you might know the etc password file contains the list of users of the Linux system. And there is another file called etc password. It actually stores the password hashes, the password of all the users in the Linux machine. And if you If you are new to Linux operating system and you are not sure about the etc password file structure, the content structure, here they gave it in a separate section here. So they clearly explain this. So in order to showcase that, I am simply referring the tryhackme machines etc file. So let me open that. Let me see the content of that file. etc password. So if I give cat, here I can see the each entry. If I see the root entry, there are 7 fields here, each field separated by colon. So let's see what the each field denotes. The first field is the username and the second field is password hash. But if you see the password hash here, all the second fields are X here. It looks weird. But what it trying to say, if you give X, it is simply referring the etc shadow file to refer, because the etc shadow file is the one which contains the password hashes. For the security reasons, they are simply mentioning X here and asking this specific file to refer the etc shadow file. And the third one is UID. They gave it as a 0. 0 denotes the top user ID, the root user ID. And the group ID again 0, the root group. And the fourth one is description, can be anything. You can also leave it empty. And the sixth one is /root, and that is nothing but the home directory of the user. And the last, the shell that the user is going to use, it is bash shell here. So this is all about the specific entry. And what we can do, if you are able to manipulate the etc password file, um, why don't we create our own entry like this and add it into the etc password file, so that we will be able to log in as the user that we mentioned. So let's try to achieve that. Before that, we need to get few other inputs. The first one is the password hash. As we said, the password is not being stored in plain text in Linux machine. It is password hash. If you have any doubt, let's go and see the etc shadow file. Actually, I don't have permission to read this file. However, once I get the root permission, I'll showcase the content of this file. The Linux stores its password in hash format, and we need to create a hash for the password that we're going to use. So here is the command: OpenSSL password -6 -salt thm, and finally the password that we need to use. So once we give this, it will give eventually the hash value. And simply we can take this line and we can replace this hash with this specific hash that we got. And once we replaced, the entry will look like this. So here is the entry. And this this is the password they used to get this specific hash. So let's try to we need to overwrite the etc file entry, but in order to overwrite, we need to spot the specific place where to overwrite that file. And for that, we need to find an offset. So let's see what is offset here. So here they gave the explanation. We have our file etc password and our content password entry. All we need now is the offset. The offset is where the file, the exploit should begin writing at. In other words, in which part we need to insert that specific entry. And to find that, we can use this simple command. And the word within this double quote is nothing but the username. You can take any username and replace, rather than replacing root. And I'm taking the username games here, and they are mentioning the password file. And once they gave this command, it will give us the entry as well as the offset. The offset is 189. We will be using this offset number while unleashing the exploit. And one more very important thing here, they are adding the specific entry within the single quote. Why they are doing like this? They are doing like this to ensure the specific entry is not overwriting the other contents of the file. Other contents of the file. So that is why they are adding the quote here. So if I go down here, if I go down further, I can see I prepared the specific entry and also offset we found. The next thing is the exploit. So far we have only the C program. We need to create the exploit, I mean the binary. For that we are using the GCC compiler and we are creating the exploit binary. So once we created everything, it is time to unleash the exploit. But before that, there is a best practice. Its C password file is very crucial. So manipulating that file without taking any backup is a nightmare. So it is best practice to take backup of this password file somewhere, and then you can carry and you can manipulate the password file. So this is all about the overview of the preparation before unleashing the exploit. So let's try to prepare the contents one by one. The first one is using OpenSSL. We need to give any password and we need to prepare the hash value. So for the time being, I'm just using the same hash here and the same entry. So this is the entry that I'm going to use, the same entry. I'm not making any change. And within the double quote, I am putting this entry. I'm just pasting it in a document. And I need to find out the offset for this specific file. So let's try to do that. I'm using grep command -b, and the user that I'm going to replace is games, and finally the file password. So once I give enter, I can see there is an user name games and the entry given, and also the offset is 189, the same number. So now we are good to proceed. And before doing that, let's take the backup. I'm copying the etc password file and putting it into the temp directory. And now I took the backup. Now all I need to do is to unleash the exploit. And in order to unleash the exploit, I am just copying this specific entry and keeping it in the clipboard. Now let's try to compile this POC and make the executable. It takes only few seconds. So GCC and the specific POC -o exploit. All right. Now the file exploit has been created. I'm using file utility to understand the file. It is executable linkable format, 64-bit, dynamically linked, not stripped. So we prepared the exploit and we are keeping the entry in our clipboard, and I'm mentioning the exploit here and the file name that I need to manipulate and the offset number, it is 189. Finally, I am pasting the entry that I want to replace. So here it is. I'm simply giving enter here. It is giving me the status, the notification as it worked, which means our exploit is succeed. That let me validate whether I really added this user entry in HC file, and let's do that. HC password. If I go upwards, I can see the entry has been created. MUIRI, and the specific entry I created by manipulating the file with the help of the exploit. Now all I need to do is, by using the switch user command, I am simply moving to that MUIRI user. It is asking the password to me, and I used the same password hash, and this is the password for that, and I'm simply copying that and pasting it here. If I give enter, now I became the root. Let me give who am I? I am the root, and I am moving to the root's home directory. Here I am, and I can see the flag. So let's read the flag. So here is the flag. So let me take this flag and put it here to finish the exercise. And this is just an advisory, and using the root shell, the original etc password file from your backup. Now we need to restore the original etc password with the root privilege. So let's try to restore the same. And for that, I'm simply using sudo command. No, I'm a root, right? I don't need to use the sudo command, I believe. So I'm simply giving cp etc password. Sorry, I need to replace from the temp cp temp password. Now I need to move to, sorry, I need to copy the specific pass wd backup file to the location etc password. Now I did that. So finished this as well. So let's move on to the next one, the second exploit. It is again a simple one. The second exploit, in previous task, we exploited dirty pipe vulnerability using Max Kellerman's original proof of concept exploit code. However, other exploits also available. If you go through the Citrix, I mean, if you go through the GitHub, you will be able to see multiple exploits related to this dirty pipe. So you can take any of those exploits and uh, try against the vulnerable machines. The original POC allowed us to overwrite the file and arbitrary data at an offset of our choosing. However, other implementations have abused the arbitrary file write vulnerability in a variety of different ways. To demonstrate this concept, a exploit script has been added to lab machine. This can be found on the target at. So there is another script. We have seen another folder called Blasty. That is where the script present. And as the directory structure suggests, the implementation was coded by Blasty. So he is the security researcher who crafted this POC, and there is another room reference. And the original exploit code can be downloaded from the Blasty's website. So here they gave the link as well. This exploit takes the arbitrary file the arbitrary file write one stage further by abusing a rather special quality of the vulnerability. So this time, this specific POC is not abusing the etc password file. Instead, it is trying to abuse the SUID programs. So what is SUID programs? SUID programs usually, uh, you can also call it as SUID bit. So what is SUID bit? If you want to understand, you can Google and you can read. Here is the explanation. SUID bit when you attempt to write them. However, this does not happen with dirty pipe. In other words, we can write to any program that has permission to execute with higher privileges without inadvertently destroying the extra permissions. So Blasty exploit capitalizes on this. Instead of overwriting the file etc password, it overwrites the user specified SUID binary such as bin su. So even I can see the bin su in the current machine. So I'm just exiting, becoming try hack me once again. I need to be try hack me before starting the exploit, and I am getting into the Blasty folder, and here is the exploit. What I can do, I can try to find the SUID bit of the specific file bin su. Here you can see the S character. It denotes the SUID bit enabled in this specific binary. So we are going to manipulate that only. So injecting the shellcode into it, which then gets executed with permission of the privileged user. So here they gave a line how the specific exploit works. Specifically, the exploit hijacks the chosen SUID binary and forces it to create a backdoor binary in /temp which has SUID bit and calls bin sh. It then restores the targeted SUID binary to the full working in order to re-adding the overwritten section and uses newly created backdoor to grant the attacker a shell as privileged user. So here in this paragraph, they explained the functioning of the new exploit created by Blasty. And the exploitation is very, very simple compared to the previous exploit. And they are compiling it and they are simply trying it against the bin su, any SUID binary. So let's try to do that. And I'm using GCC and the file name -o. Once again, I'm naming it as exploit. The file exploit is a binary file. Uh, excuse me. It's a binary file, executable and linkable format. And we are directly trying this against the SUID by SUID bit enabled file. Now you can see it gave me a root shell. Who am I? I am the root, and I can see the folder. And let me try to move to the home page. Home page of the root. Here I can see the flag file. Cat. I think I am in the restricted shell now. Oh yeah. Here is the flag. So even like this, we can manipulate. We can exploit the dirty pipe, and it is just an advisory, and remove the SUID binary created in the script. So let's try to read the temp directory. There is a file sh, so they are asking us to remove that file, and find another exploit that is vulnerable online. This is just an exercise that you can do. You can try to find another exploit, and you can try it against the machine which is affected. So again, it's an advisory. So moving on to the conclusion, they are just uh, giving a message about the accomplishment. If you want to look at the CVE in more depth, you are recommended to view the blog post. Again, they gave the same blog post link of Max Kellerman. You can, we recommend to, they are recommending to refer this specific blog post. So this is all about this room. Again, it's an advisory. With this, we are completing this specific dirty pipe vulnerability room. I hope you really enjoyed this. You learned something new from this room. If you really did, hit the like button and consider subscribing my channel. You can also share this video among your friends. And if you have any opinion, put it in the comment section. I'll try to read and answer for your questions. And yeah, this is all I wanted to share. I'll catch you next time with another exciting and excellent concept. Until then, I'm signing off. Cheers and love you guys.